Good day, students. How are you today? I hope you are all doing fine. So today we are going to discuss our next topic, which is about uncertainties and error analysis. But before that, I would like to show you this picture. What can you say about this picture? Are there any problems with regards to the measurement done by the engineers or contractor? If there is, what are those? So if you can see the output, we can say that the bridge they built are not in the same position. They are not aligned. So there is a tendency that para maayos, kailangan nilang. So based on the picture, there are a lot of possible causes. It's either systematic or random errors. But most measurement causes uncertainties due to the following. First is the measuring device. Second is the experimental technique used by those scientists or researchers. And the last is because of the nature of the measurement itself. Just like, for example, the weight of a grain of sand. Because naturally, we cannot measure the grain of sand unless it is in tablespoon or in a cup of sand or in a handful of sand. Am I correct? Now, there are also uncertainty in raw data. When you say raw data or raw, these are the data which were not yet solved or used in the process or solutions. So for example, nag-measure yung isang tao, yung nakuha niyang measurement, yun yung raw data na tinatawag. So when your instruments are analog devices, you can measure the uncertainty by means of dividing into two the smallest increment on the measuring device. So it means it is positive, negative, half of the smallest increment on measuring device. So for example, in a metric ruler, the smallest number here is 1. So meaning to say, you are going to divide into 2 the smallest increment. So the uncertainty will be positive, negative, 0.5. Now, try the following. So in letter A, for example, we will assume this line above as the pencil. So as you can see in the letter A, what is the total measurement based on the use of the metric ruler? So it is 9.5 positive negative 0.5 centimeter. So why is it 0.5 centimeter? It's because the smallest increment in letter A is 1. So half of that is 0.5 centimeters. Next, letter B. What about here? What is your measurement? So it's 8.5 positive negative 0.25 or approximately 8.5 positive negative 0.3 centimeter. So in writing the final answer here, you must estimate the uncertainty. It's because you need to equal the number of decimal places based on the given value. So since the given value is in 1 decimal place, therefore your uncertainty must also in 1 decimal places. That's why you need to estimate. What about in letter C? So in letter C, we estimated that the measured value will be 11.9 positive negative 0.1 centimeter. Take note that the number of decimal places of uncertainty must be equal to the number of decimal places the measurement has if you are going to measure using the analog instrument. Do you understand? Now, another example in graduated cylinder. So, based on the reading of the meniscus, the measurement is 31.9 positive negative 0.1 ml or milliliter. Now, if you are going to use the digital scale or the digital instrument, the uncertainty must be positive, negative, 1 part of the smallest reading. So, for example, in this picture, the smallest reading is the first decimal place. So, the uncertainty would be 0.1 grams. Now, if you are doing a repeated measurements, you need to find the average first of all the trials done during the measurement. And then after that, to get its uncertainty, you need to divide the range by 2. So for example, Ming measures the height of a chair 5 times and get the following results. So since they are repeated measurements with 5 trials, therefore you need first to get the average value. This average value will be your measured value. So to get the average value, you add the measurements and divide it by the number of measurements. So the answer will be 2,504 millimeters. And then after that, before getting the uncertainty, you need to get the range. So the range is the equivalent of the highest value minus the lowest value, which is equivalent to 9 millimeters. Now get the uncertainty by dividing the range into 2. So your answer will be 4.5 millimeters. But since this measurement is used by an analog devices, because you are measuring the height, your uncertainty must be estimated based on the number of decimal places the measured value has. So since there is no decimal places in the measured value, therefore, your uncertainty must also estimated into a whole number. So your 4.5 will become 5 millimeters. So the total height of the chair with uncertainty is 2,504 positive negative 5 millimeters. So pag sinabing uncertainty na 5 millimeters, either ang kanyang height is 5 less than the measured value of 5 more than the measured value. So pwedeng sabihin natin na yung kanyang true height is in between 2,499 and 2,509 millimeters. So in uncertainties, there are different types. The first one is the absolute uncertainty. Absolute uncertainty is the certainty you get from a measurement. It tells how large the error is. So for example, from the previous given, the height of your chair is 2,504 positive negative 5 millimeters. So it means ang kanyang absolute uncertainty will be 5 millimeters. Another type is percent uncertainty. This percent uncertainty is calculated by dividing the absolute uncertainty to the measured value and multiplied it by 100. This percent uncertainty is also known as the relative uncertainty. It tells how large the error in relation to its true value. Ibig sabihin, gaano kalaki ang error niya sa true value na given. So for example, from the previous answer, which is the height of the chair is 2,504 positive negative 4.5 millimeters. So using the original answer of the absolute uncertainty, 4.5 divided by the average value of the chair, which is 2,504 times 100. So your answer is equal to 0.1797124.6% or approximately 0.20%. So we use the two significant figures. It's because based on the rule, it states that when the uncertainties are greater than 2%, you need to round it off or estimate your final answer into one significant figures. But if your uncertainty is less than or equal to 2%, you need to estimate your answer into two significant figures. So since the calculated answer, when you divide the 4.5 millimeters to 2,504, your answer is in less than 2%. So therefore, you need to estimate it into two significant figures, which is equal to 0.20%. Do you understand? Another more example. So in the table below, we have the measurement of density and weight and their corresponding absolute uncertainty. So to get the percent uncertainty of the density, you divide its absolute uncertainty, which is positive negative 0.1 grams per centimeter cube, to the measurement, which is 1.15 grams per centimeter cube, and multiply it by 100. Next is the weight. So your weight, the absolute uncertainty is positive negative 1 gram. Divide it by its measurement, which is 59.67 grams. So therefore, your percent uncertainty will be 1 gram divided by 59.67 grams times 100. So your final answer in density percent uncertainty is 9%, and in weight is 1.7%. Is it clear? So for further questions, you can PM me in Messenger or Edmudo. This will be the end of the first part of our lesson regarding uncertainty and error analysis. So see you on the second part video.